Okay, in this video we're going to talk about complex division. So we've already seen multiplication, addition and subtraction. Division is going to follow a process similar to what we use to get surds off the bottom of a fraction. So for example, if we take something like this, what we want to do is we want to times by something called the conjugate. So that's going to be 4 take 2i and 4 take 2i on the top and the bottom. So the conjugate just means if you got a plus, you change it to a take, or if you got a take, you change it to a plus, and it should look like that. The whole goal of this is to do a difference of 2 squares on the bottom, because if I call this thing A and this thing B, then it sort of follows down with that formula down there that we can see. So let's step this all out and see what we get. On the top, you're just going to get 1 plus 3i and 4 take 2i. We'll FOIL that out later. But on the bottom, you're going to get 4 squared take away 2i squared. All right, so what do we get on the top? Well, you're going to get 1 and 4. You're going to get 1 and minus 2i. You're going to get 3i and 4. And 3i and minus 2i. Something like that on the top. On the bottom, you're going to get 16 take away 4i squared. All right, let's keep going. So you're going to get 4 take 14i on the top, essentially. Now this minus 6i squared becomes a plus 6 because I squared is minus 1. And then it cancels out with that other minus. It becomes real. Similarly, this becomes 16 plus just a real 4 on the bottom. Notice how there's no imaginary number on the bottom. This is exactly how it worked to get surds off the bottom of a fraction. So 4 plus 6 on the top gives us 10. Take 14i over 20. And that's about as simple as you're going to get. There's a couple of different ways you can write it. So what you can do is you can sort of halve the top and the bottom, so you could get like 5 take 7i over 10 if you want. That's considered a little bit simpler. Or if you want to get extra fancy, you could get, I guess it would be 0.5 plus 0.7i if you want to write that as just a real bit and an imaginary bit. We'll see later that we're going to represent complex numbers on a plane, and it's really helpful to just write it with a real bit and an imaginary bit rather than in a nasty fraction like that. Similarly, if we want to simplify something like this, this is a bit easy. You just times it by I over I and see what happens. So you're going to get I on the top, and you're going to get I squared on the bottom. So I over minus 1, or if you like, that's just minus 1 lot of I.